Hello, this is my third period geometry final project for Mrs. G. For this project, we have to find the volume and surface area of multiple common shapes. So first, let's start with a prism, and for that we have this box, which is essentially a right angle rectangular prism. And so the formula for volume is length times width times height. So we measure it and we find that its width is 5 inches, its length is roughly 2.75 inches, its height is 2.50 inches. And so you basically you're taking a base, times it by the height to get the volume, and if you do that math, you get 34.375 inches cubed. And so that's simple. This is basically the first volume thing you learn. And now for the surface area. So the way basic surface area works, take a base like this, and then it's going to have a base on the other end. And then you need to find the lateral area, which is everything surface area-wise between these two bases. And so it's lateral area plus 2 times base area. And the way you find the lateral area of a right rectangular prism is the perimeter of the base times the height. And so in this case, since the base that I'm using is if you think of it as a 2D shape, if you think of it as base is 257 to 2.5. And so if you time each of those by 2 and add them together, you get 10.5. And then if you time that by the height, which is 2.5, you get 26.25. Then you need to find the area of the base, which is you just, again, as if this is a two-dimensional shape and you're finding the area. And that is 6.875. And the area of the base is doubled. Well, the area of one base doubled because there are two bases is 13.74. And you add that together and you get 39.99. And so the surface area of this box is 39.99 inches squared. I also have another novelty box for us to use. It's a Menorah box, and we're going to see something a bit different with this one. We got this box, and so again, finding the volume is the same thing. We need the width, which is 475, and then the length, which is also 475 because this base here is a square. Then the height is 175, while the others were 475, and you already know the formula, and it comes out to approximately 39.48 inches cubed. That's the volume of this box. And then to find the surface area, we need the perimeter of the base. But since this base is a square, rather than adding it together, we can just do 4.75 times 4 and get 19 as the perimeter of the base. And the lateral area is 19 times 175, so we know that the lateral area is 33.25. And the area of the base, you do 475 times 475, and you get approximately 22.56. And then since the area of the base is doubled, you get 45.125. When you add the lateral area and the area of the base together, you get the surface area, which for this box is 78.375 inches squared. Now that's the last when it comes to prisms. And so now we have a cylinder. And if you ignore the indents, this pencil sharpener is functionally a cylinder. And the formula for the volume of a cylinder is pi times radius squared times height, which again is just like how you take the base and then you times it by height. That's the formula for the area of a circle times height. And unless the numbers work out really well, I'm just going to be directly using pi as 3.14. So I don't have like two answers and one's an answer that you don't have a frame for reference for. So the best way I find to calculate radius is to actually find diameter if you're doing it physically. That way you don't have to try to figure out what the center of the circle is. And you got to make sure to do it with the sides. For this shape, do it with the sides with no indents. And if you do that, you get that the diameter is 4 centimeters, so it means the radius is 2 centimeters. Using the side without the indents, you get a height of 5.5 centimeters. And so you put that into the volume formula, so the radius square is 4, and then 4 times 5.5 is 22, and then 22 pi is approximately 69.08. So the volume of this pencil sharpener is approximately 69.08 centimeters cubed. And the surface area formula is the same as for a prism. And so the formula for finding the lateral area is 2 times pi radius times height. And the lateral area for the shape is actually 69.08. And the reason why it's the same as the result for finding the volume is because 2 times 2 and 2 squared are the same thing. So the addition of the 2 in this case means that 2 pi times radius times height is the same as radius squared times pi times height. And so we have the lateral area, and so now we need the base area. It's the formula for the area of a circle, pi times radius squared, which is 12.56, and that times 2 is 25.12, and add the lateral area to that, and you get a final surface area, which is 94.2 centimeters squared. The surface area is more than the volume because it's so small, and that's what happens when things are small, and then eventually you get more volume than surface area. It's how cells work. So that's one of the cylinders we have. We have another cylinder, which is this spool of ribbon. And so we take the spool, we measure its diameter, and for that we get 10 centimeters, so a radius of 5 centimeters. For the height we get 2.5 centimeters, and we do the same set of math as last time. We get a volume of 196.25. And so for finding the surface area, we need the lateral area. So you do the math, and the lateral area comes out to 78.5. And then the base area is also 78.5. And that is because 5 squared is equal to 25. But 2.5 times 2 is also 25, and then they're both timed by pi, which is how the lateral area and the base area for the cylinder is the same. Because they're the same value, rather than having to multiply the base area by 2, you can just times 78.5 by 3 and get the surface area, which is 235.5 centimeters squared. So that's it for cylinders, and now on to the only pyramid I could find. This is going to be a bit awkward. It's a standard sized D4 or 4-sided dice, and this is like the standard size you'll find in most RPG dice sets. Means it's very small, but I don't like having to make the shapes physically because then they'll be irregular. Well, this one I can rely on. This is a pyramid with a triangular base. The formula for the volume of a pyramid is a third of the area of the base times the height. And so the area of the base is whatever the formula for finding the area of the base is. If this was a square pyramid, you'd find the volume of the square, but this is a triangular pyramid, and also all the bases, everything is actually the same because it's a dice, and that all of the sides are bases. So if we just choose one arbitrarily to be the base and then switch in the middle and use a different base, it'll still work. And so for what we're going to need is we're going to need a side, and that's basically 0.8 centimeters or 8 millimeters. And every single side here is going to measure 8 millimeters. So measuring the height, you also get 0.8 centimeters or 8 millimeters. So you do 8 times 8, divide it by 2, you get 32. So the base area, or really the area of any of the faces, is 32. And then for the volume, you times that by the height, and you get 256. And if you divide that by 3, you get 85 and a third. So for finding surface area, the lateral area of a pyramid is the perimeter of the base times the height of the pyramid and half of that. So the perimeter is, this would be for the base, so you'd be finding the perimeter of a square or a rectangle if that was the kind of pyramid it is, but for this you just, and since it's an equilateral triangle, you just do 8 times 3, and so you find out the perimeter of any of these faces is 25, and then times the height, you get 192. Half of that is 96, so the lateral area is 96. And once again, the base area is 32 millimeters. And however, this surface area formula is different. Because there's only one base, it's actually lateral area plus the base, which is 128. So the surface area of this D4, and most standard D4s, is 128 millimeters squared. And so now the cone, the only shape I actually had to make, and so you can see the bottom is a bit irregular, but it's conical enough. So the formula for finding the volume of cone is very similar to the formula of finding the volume of a pyramid, because they're kind of the same thing, just a cone has a circular base. It's a third of the area of the base times the height, and because the base is always going to be circular, the base area is the formula for the area of the circle, pi times radius squared. And so we need to find the diameter, and it's a bit rough here because of how it's irregular, but if you bring it around, it's basically 2 inches, which gives it a radius of 1 inch, which is going to make things interesting. And then again, going around a bit because it's irregular, you end up with a height of about 8 inches. And so we'll use 8 inches as our height. And so to find the base area, because 1 squared is 1, the base area is pi, or 314, and that times 8 is 8 pi, or approximately 25.12, meaning that the volume is approximately 8.37 inches cubed. And then for finding the surface area, we'll need the base area, which we already have, it's just pi, and we'll need the lateral area, which is pi times radius times height, which means the lateral area is 8 pi, or as we already know, approximately 25.12. And because it's just like a pyramid, you don't double the base area, you just add the values together. So the surface area for a cone is 28.26 inches cubed. And now we go on to the sphere. Its formulas are structurally fairly different from the other ones we've reviewed before because it has no base. It's a circle. It's weird like that. It does what it wants. Obviously, the only input value is the radius, which means we're going to need to find the diameter, which I'm not really... This is my best approximation of how to do it with a physical sphere. So you put your fingers around what's basically the center line. Now, if you were to do something like this, obviously more would be added. This isn't the most direct route because it has to curve over it. So what you have to do is careful to, well, this is the method I figured out. There's probably another one that's actually more accurate. You hold it, and then you gotta pop out the sphere, keep your fingers in the same position, and then from the edge of one finger to the edge of the next finger, you'll get approximately your diameter, which for this tennis ball is 7 inches, which gives it a radius of 3.5. And so the volume formula for a sphere is 4/3 times pi times radius cubed. This radius cubed is 42.875. When you times that by pi, you get approximately 134.6275. And now we got to set that up like a fraction. We can times it by 4/3, or otherwise times 4, which is 538.51, divided by 3, and for the volume you get 179.503 repeating, which in fractions comes out to 1.75 and 151/300ths, which are both unwieldy numbers, but at least one of them isn't repeating. And this is obviously in centimeters cubed. And then you do something similar for finding the surface area, except now it's just times 4, and the radius is only squared. So when you square this radius, you get 12.25, and you times that by 4, and you get 49, which times pi is approximately 153.86. And so the surface area of this tennis ball is 153.86 centimeters squared. Now there is one more sphere I have, and it's actually in the dragon box. It is an orb. These orbs are the same size, so I'm just going to use one of them. Now we got to do the same thing to find the diameter. Yeah, it's easier to do. I took these measurements ahead of time, and it's much easier to do when you don't have a camera, and so it's slightly more accurate than what we're coming up with here. That's approximately 4.5, which means the radius of this orb is 2.25, and so we plug it into the same volume formula. The radius cubed is approximately 1139, which times pi is 35.7646, which we put in as an equation, times by 4, it's 143.0584, divided by 3, we get a bit more reasonable of a number. 47.686 centimeters cubed is the volume of this circle. So now when we square this radius to find the surface area, we get 5.0625, which times 4, it actually comes out to a reasonable number of 20.25, and that times pi is 63.585, so the surface area of this orb is 63.585. So these are all the shapes I've measured for this project. If you have any questions, I haven't decided if I'm going to be releasing this video publicly or not. So either you're my teacher or you're, like, I don't know, maybe she uses it to teach future students. If you have any questions, if I haven't explained something properly, please leave a comment and I'll try to address your concern the best I can.